Okay, there's a quick screencast, and we are going to work on graphing and solving by graphing. So there's basically two methods that you could use to solve this type of equation by graphing. One way is to graph this side of the equation. It'll be some line or curve or something. And then go ahead and graph this side of the equation as a separate equation. That'll be some graph or curve. And you can basically find the intersection points using that tool on your calculator. Whenever you find those intersection points, you'd really be wanting to figure out what those x values are. So the x values of the intersection points would be your solutions to this particular problem. Let's go ahead and graph this. So I'm going to graph 2 to the x minus 15. And I can barely see it there. That's okay. Hit tab and graph the right hand side here, which would be x to the third power minus 50 x squared minus 12. Okay, I can't even really see that one. I'm going to hit the zoom, window zoom, zoom in. Maybe I should zoom out, actually. That might work out a little better. Okay, I'm going to zoom out here. Well, I think I've zoomed out enough. I can kind of see where this, where these two graphs cross right there, but it's really tight there. So I'm going to maybe adjust these values, maybe 2 and negative 2. That's actually pretty good right there. So it crosses, looks like, in two spots. Let's hit the intersection point. So if you hit the menu key, geometry, points and lines, intersection point. You click on one graph, click on the other graph, and both of the, notice I hit escape too, so I can grab these. Both of these intersection points come through. So let me just kind of grab this. So in this case, we have our solutions, which are going to be the x values of these two intersection points. And so I would write my solutions like x equals, I just said x equals negative 0.21, round that off. And the second one would be x equals 0.19. And those are my solutions. Now there's another way we could have done this. So I'm just going to show you that way, and you may like this way a little bit better. So that was F1 and F2. Here's what I'm going to do. So I'm going to do, let's see, insert a graph, go up to F1, and I'm going to really solve this equation. So let's go ahead and, if I subtracted x cubed and added 50x squared and added 12, so I'm going to move all these to the other side of the equation. The only thing left over here on the right side of the equation is 0. So my new equation would be 2 to the x minus 15 minus x cubed minus 50x, plus 50x squared plus 12 equals 0. So I set the whole equation equal to 0. Well, now we're going to have a little different method when we solve this. So let's go ahead and tack that on here. So it'd be minus x to the third plus 50x squared plus 12.
Yeah.
And so when you look at this and you do the trace, so menu 5 once, if you like tracing, this might be the method for you. And you can see there's a point, a 0 I should say. There's a 0. I press enter to lay down the actual ordered pairs there. Here are my two ordered pairs, and notice in this case my solutions are these two x values. So it's here and here again. You're looking for the x values either way, and so I wouldn't put the ordered pair, I'd put x equals 0.19. x equals negative 0.21. And that's the two different methods you could use to find either the intersection points or the solutions. But in both cases, you're finding the solutions of the particular graph that you're finding.